In this video, we're going to review the order of operations. Anytime you have an arithmetic problem that has more than one operation, you have to do those operations in the correct order in order to get the right answer. And so this is the understood and agreed upon way to do that. First of all, do things inside parentheses before you do anything else. Evaluate those anything inside of parentheses first and get that down to a single number. Okay, but then either inside parentheses or once you're done with your parentheses, the order of the remaining arithmetic operations is as follows. First, you do any exponents, or in other words, raising things to powers that may be called for. Then you do multiplications and divisions, and you do those left to right. So just working through your problem from left to right, any multiplications or divisions, you do them. And then any additions and subtractions, which is what you'll have remaining, do those left to right. And so this is often, people remember this with a mnemonic device of Pemdas. Some people just remember Pemdas. Some people remember a sentence that goes along with this: please excuse my dear Aunt Sally. But however you want to remember it, this is the procedure. So P stands for parentheses, E stands for exponents, M and D are multiplications and divisions, A and S are additions and subtractions. But I want to warn you that people who remember PEMDAS or please excuse my dear Aunt Sally sometimes forget that multiplications and divisions are at the same level of priority. And so you sometimes do divisions before multiplications if the division comes first when you're going left to right. Sometimes people think because M comes before D in PEMDAS that you do all your multiplications no matter where they are, then you do all your divisions no matter where they are. And that is not true. Multiplications and divisions are tied for priority. You just go left to right. And the same with additions and subtractions, A and S. A does not come before S here, really, in the order of operations. They're tied, and you just do whichever ones come first as you go left to right. So as an example of this, if we had just really simple 10 minus 3 plus 6, so there are no parentheses, there are no powers, we don't have to worry about that, and in fact there's no multiplications or divisions. There's just additions and subtractions, and we're just supposed to go through left and right and do them. So you would do 10 minus 3 first because it's to the left of this plus, so we would do these and make it a 7. And then we would do the addition and get 13, and that would be the correct answer. You would not do the 3 plus 6 first, get 9, and then do 10 minus 9. You would get 1. That would be a different, incorrect answer. So that's an important point, that this is an example where we did the subtraction before the addition, and that's the correct thing to do. All right, just to do one or two more examples. If we had 6 plus 10 divided by 5, we would do, so again, no parentheses and no powers, so forget about that. But we would do the division first. That does come before addition. So we would do 10 divided by 5 and get 2. So we would have 6 plus 2, and that would be 8. Now on the other hand, if the addition was meant to be done first, then it would have needed to have been written like this. We would have to put in the parentheses to force the addition to come first, right? Because anything inside parentheses must be done before anything else. So then we would have 16 divided by 5, which would be, well, 16 fifths or 3 1/5, or however you want to write it. Okay. And I guess I'll do one that has a power. We could do 5 times 2 plus 6 times 3 squared. Okay, so first we would do the power, the exponent. That would become a 9, so now it's 6 times 9. Okay. Then we would do multiplications, so this would be a 10, and this would be a 54. And then finally we do the addition, and we get 64. That would be the right way to do that problem. Okay. One other point on order of operations is division. So now sometimes we write division with that symbol, right? But actually, as you go further in math, the more common way to write division is as you actually use the fraction bar. So for example, you might have something like 6 plus, well, here, let me not get to that part yet. Let me just do something simple. If you just had like 9 divided by 3, many people might just write it like that. 9 over 3 means 9 divided by 3. And that just equals 3, right? So using a fraction bar often is the way we write division. In fact, that's what this symbol originally meant. It's a fraction bar, and the 2 dots are saying, well, 2 numbers here. It's saying the 9's really here, and the 3's really here. And it was just a way of writing division back in the old days when you were typesetting things and things had to be all on one line. It wasn't possible. It wasn't very easy to write a fraction like this. So making things all be on one line, they used this symbol. Okay, but my point on this is that when it comes to order of operations, fraction bars sometimes work like parentheses in a way, even though there are no parentheses there. So this is what I mean. 6 plus 4, and then I'm going to put a fraction bar under the whole thing, and then I'm going to put a 2. Right? So the fact that the fraction bar, that the 6 plus 4 is completely on top of the fraction bar, that does mean you're supposed to do 6 plus 4 first. It's as if there are parentheses there, but we don't usually write those parentheses. We could have, but it would be redundant because the fraction bar extending under the 6 plus 4 means the same thing. It implies the same thing. And so we would do 6 plus 4 first, and then 10 divided by 2 would be 5. Okay. And this gets a lot of people. I don't know that problem as it stands gets a lot of people. Sometimes it trips people up. But where it trips people up is if you type this into a calculator. Because most calculators, except the newest and best ones, as I was saying before, they sort of force you to put everything on a single line, and you can't do fraction bars, right? So you use the slash for division instead. Well, on some calculators. Actually, on some calculators, they do have the division symbol as well. But whatever it is, if they force you to put it on one line, if you were to put that into a calculator as 6 plus 4 divided by 2, see, the calculator would not realize that the 6 is also on the top of that fraction bar with the 4. It would think that it was 6 plus 4 divided by 2, right? The calculator would not know that the 6 is supposed to be up there. And so if this is what you were trying to type in your calculator, you would have to now be responsible for putting in the parentheses that are understood here. The fraction bar is doing that work in this problem. And so you would, if you break it apart like this and put it on one line, you would need to include parentheses. So that can be confusing, and I see students make that mistake all the time, and it's very reasonable because of the sort of translating between how we write math and how we type math into a calculator. So that doesn't come up all the time every day, but it's something to keep in mind. This has led to many an incorrect answer for students.